Welcome, everyone. You are in the right place to see Roadmap to BIM for Owners, the OSU Journey. Your presenters today will be Peter Costanzo of Imagine It and Joe Porostowski with the Ohio State University. Gentlemen, the floor is yours.
Well, good morning, everyone, and good afternoon. Thank you for joining us. We're here for our webinar today. We're going to talk for about 40 minutes. We want to leave time for questions and answers. Let's get to it, Joe. So next slide, please. So just an agenda. I'm going to do a little introduction. I'm going to do three slides to kind of paint a picture about what some of the problems are with BIM for facilities management. And then Joe is going to talk in depth about what he did at OSU to address those problems. And then we'll have time for questions and answers. So from an introduction standpoint, Joe's the better looking guy on the right. Joe has been working with OSU for about 11 years now and has moved almost all of their entire campus from CAD to BIM, which he'll talk about a little more in detail. My name is Peter Costanzo. I head up the FM practice here, and I've had the pleasure of working with Joe for the last couple of years. So as we talk about BIM for FM, and you talk about different technology adoption curves, we've got a lot of owners on our webinar today. We've also got a lot of AEC professionals. And from an AEC professional standpoint, kind of the laggards are adopting onto the technology. From an owner's perspective, we're kind of at the beginning of that trend. And part of the reason why isn't that BIM hasn't been around for a long time, but it takes years to construct a building regularly. And also, as you look at you're managing facilities, usually you're not in a brand new building, so you've got buildings that have been around for a while. And when BIM went through its implementation in the AEC community, they had to change the way they did things. And the same thing kind of needs to happen from a facilities management perspective. And the chart at the right is a thing I pulled from McGraw-Hill, which basically says, hey, the use of BIM continues to grow, and it's growing very drastically. There's just one problem that's associated with that. And Joe, if you could just hit the next slide. We're kind of caught in the lose-lose part of the standard thing. People will talk to you, hey, are we lose-win, or we win-lose, or we win-win? We want to be in win-win. And there are two main reasons for that. From an owner's perspective, a lot of owners don't understand BIM. I've seen AutoCAD drawings, which are supposed to be BIM. The other thing that happens is you talk about BIM as a process, the wrong people are engaged. In a perfect world, BIM offers a facilities manager the holy grail about their facilities. Not only can they know where their things are that need to be maintained and taken care of, but they can have detailed information about that. And the other problem you have is that the AEC community is used to talking to design and construction. They're not used to talking to people in facilities. And to steal a line from a friend of mine, Chuck Meese over at Autodesk, unless you're talking to the guy with the name on his shirt that's out fixing things at an owner, you're talking to the wrong people about what BIM data will help them manage their facilities over time. And the same thing we kind of look from an AEC perspective. They're talking to design and construction, and partially all of this, you need a secret decoder ring, which I'm going to show you in a second, which is very simple. You just want to change how you're having the conversation and change that paradigm, and then things snap right into place. So as we move along from a solution set, and Joe, could you just cue the next slide? We have what we call the three questions. And when I present these to an IT department, the IT people laugh at me because these are questions they ask for everything. So as you're looking at BIM from a facilities perspective, you want to ask three things. The first question you're going to ask is, what data do you need? And you'll get a list of different things, and it will start with, hey, where are things? So building floor, room, asset, some information about the asset. Once you get that list together, you go on to the next part of the question is, how are you going to collect it? And as we do this, BIM becomes a little bit more interesting because BIM, depending on who you talk to, could mean different things. So Autodesk in Autodesk Revit is their BIM authoring tool, and we can have all sorts of information in this, but you've also got commissioning software that you might use. You might use point cloud scanners and be taking point clouds and pictures during the process. So as you start to think about that data, you're going to think about when you're collecting it. And an example that I often use is that, if you're tracking pieces of equipment, it's not and giving them a unique identifier so you can track them over time to maintain them. Usually, the unique identifier on that piece of equipment is a barcode someone's slapping on during the commissioning process. It isn't done in a nice, clean desk where someone's working inside of Revit. So you're going to think about it. It's how are you going to collect it, and also what kind of sources, because there are different sources that are involved. And then the third thing that I love makes this whole thing much easier. You ask how it will be kept up to date. And all of a sudden, that long list that you have on that first one, what data do you need, that list gets much shorter because, like all systems, it's garbage in, garbage out. And when not only do you need to worry about keeping information up to date, but most information in facilities at owners is kept up to date by the facilities management department. And at some point, the budget's going to get cut. And the facilities management department still needs to screw in the light bulbs. They still need to maintain the equipment and change the filters and fix what's broken. But one of the things that's the first to go is maintaining of their building data. So as we look at these three questions will help guide you, and it makes looking at BIM a lot easier. Today, Joe is going to talk about his journey and what he went through, and we worked closely with him on this. And what we're going to show you today is kind of a roadmap of how Joe did things, and we worked with him on this, and we developed a product called BIM Switch out of it. And BIM Switch has three key pieces, which Joe will kind of work through. The first is it's got some processes to make sure that as you're creating your BIM data, you're getting good, clean data that is usable for different groups and portable. The second thing that was involved is a content library, and the content library that was created was very simple, which would allow OSU to have lightweight models and have then later on tie information to those models. And then the third piece, there are a bunch of productivity tools, which I'll use for lack of a better term, were a couple different software solutions that Joe used that helped him move quicker in their process and be more efficient. And with that being said, I turn the floor over to Joe.
Thanks, Peter. Thanks all for joining us today. And I'm looking forward to chatting with you about our Buckeye BIM initiative and what we've been doing at Ohio State over the last 8 or 9 years, actually. And really this breaks down into three different parts from our perspective. We have BIM for existing buildings, which I'm primarily going to talk about this afternoon. We also have been doing a lot of work around BIM for design and construction. We recently published our fourth version of our BIM project delivery standard, which is required in all projects over $4 million. And we increasingly are using both of these top two initiatives to drive utilizing BIM in operations, which is where we see the biggest bang for our buck. But it's also one of the harder areas to start seeing value. You have to make sure that you've thought through carefully the first two to get value into the third. And we think about this as a continuum between build, maintain, integrate. We're building models of our existing campus. We're maintaining those models over time, and we're integrating data that we receive from the design and construction process, especially those projects that require a Revit deliverable in our case. Just to give you a little idea of our timeline, we've been working on this for quite some time. We started seeing where the industry was going with BIM and Revit back in 2008, 2009. Didn't really feel like it was time for us to start moving on it. Technology was maybe just a little bit too immature. But we started getting serious in 2010. We actually hired a student for a summer and said, hey, we don't understand this Revit thing. Go build us a model and let's see what happens. We didn't give many instructions. We just said, figure it out. And from that, we were able to at least get a sense for the value of having a three-dimensional model of our buildings as opposed to our existing 2D AutoCADs. And so we were able to get some funding to start within our medical center. And in 2011, we kicked off work with our consultants, to develop some of what you're going to see today, a lot of what you're going to see today, from a standards perspective and a process perspective. The tools didn't come actually till later. And then we used 2011, 2012 to actually build out the first 53 buildings and 6 million square feet, which were in the medical center. We learned a lot of lessons from that first set of buildings, and then picked up again in 2013 to begin completing the rest of the university, and learned a lot more lessons, obviously, as we got into different building types along the way. So I want to focus now just on our BIM for existing buildings and kind of where we've come and why we've done it. For most of us, especially owners, we're still in the world on the left where we have 2D AutoCADs, and honestly, those are better than paper drawings, right? But at the end of the day, they're dumb drawings. They don't have any intelligence about themselves. They're helpful to understand our space. It's easy to measure, but we wanted to move on to more intelligent model of our building, not just simply a set of floor plans, but a model of our building. We wanted to understand exteriors. We wanted to understand a 3D perspective of our spaces. We wanted to do different things with our models than just lay out some 2D furniture. We wanted to look at that three-dimensionally and improve our ability to describe maybe a particular furniture layout or renovation that we're going to do. We want to understand adjacencies, and we wanted the value that Revit brought in being truly a database with a drawing component to it. We wanted to be able to utilize our building models in more ways than simply 2D drawings. And so we began this process of then converting our buildings. And really, our focus was along the entire way is how do we help our organization, Ohio State, make better decisions more quickly? And my team has all sorts of different types of data, primarily around facilities. And moving to more of a 3D environment, Revit-based environment, was going to help our organization make better decisions more quickly in a lot of different areas, from renovation planning to donor recognition, to the way that we maintain our facilities, to even things like cleaning. And there are lots of different use cases that we've seen come out of utilizing three-dimensional environment. To this point, we are 88% complete with converting our entire university from AutoCAD to Revit. We have 319 buildings, which is 32 million square feet in Revit. This is a lot, and we've learned a lot of lessons from trying to manage this many buildings. And at the end here, I'll kind of share with you some of the big lessons that we've taken away from converting and then having to manage this much square foot within Revit. We hope that we're going to be done in about the next 2.5 years. We're getting into our regional campuses and our satellite locations, and so those present their own difficulties. When we're done, we'll have around 36, probably 37 million square feet, because we're always building, and we'll probably have some new buildings on campus by that point. But we should be 100% Revit within the next, I would say, like I said, 2.5 to 3 years. One of the first things we had to think about when we started moving this direction back in 2011 is what is an owner's model? What does that mean for us at Ohio State? And how do we define that? And you've probably heard the terms design intent or work intent or as built. And we like to think of the owner's model as our as maintained model. It's what we say we're going to maintain over the long term. And if you think back to those 3 questions that Peter already mentioned, these come right back in right at the beginning of our process, is really asking ourselves, what do we need? What do we not need? And we didn't make that decision on our own. We met with a lot of our customers saying, look, we're going to be transitioning to a 3D platform. And here's what we have in our AutoCADs today. And what do you want? Is this information useful to you? Is there some additional information you'd like in the model in the future that we're not collecting currently in AutoCAD? And thinking through all the different types of customers that we have and what do they need and what do they really not need? And really trying to answer the question, at least initially, what supports our planning efforts? We're still on the planning side of the house, and although now we support the operations side way more than we ever have, our initial question when developing these models was around the planning side of the house. Now, if you ask enough customers, at least enough of our internal customers, what they want, you're eventually going to put every last thing that's in that building in that model, because everybody wants some piece of that building. And so you do have to really think through what's going to be the most valuable stuff that's going to help the most people. And really coming to this last question, again, back to the 3 questions, what can we reasonably maintain? I only have so many people on my staff. I need to make sure that if we're going to put something in the model, that I can maintain that over the long term with the staff that I have. And so we came up with a list that made sense to us. Our basic model has these items, basic walls, windows, doors, and columns. We had some casework, depending on what kind it is. We had some basic plumbing, so you understand what you're looking at. And you can see the rest of the list here. Now, there are a couple of different types of buildings, like athletic facilities, where we add the playing surface and seating, or in residence halls, we tend to add more fixed furniture, and we have a defined list for there too. But one of the things that's been important to us is to stick to our defined list. It's easy to say, well, in this building, let's add a couple extra things. But what ends up happening is that you have scope creep, and eventually you're having a hard time getting things done simply because you're adding too much to every single building. So we've been very, very careful about sticking to the list that we developed. Sometimes we have a student that goes rogue on us because we have students that do the majority of our modeling, and they want to over model, and they're trying to do the right thing, they're trying to do something better, but we need to get these buildings done. We can always add more data later, and so that's the way we've kind of approached it. So we started off by developing standards. We were moving into a new environment, very, very different from AutoCAD, and we had to think through, how did we want our Revit file to look? How do we want it laid out? What do we want our title blocks to look like? What do we want our project browser to look like? What kind of views are we going to have? What kind of sheets are we going to have? What kind of schedules are we going to have? And how is this all going to be organized? We wanted to get this as right as we could up front, so that we'd have a consistent way of managing our models through the duration of the project, and then throughout the life cycle of a building. And part of that was just coming up with naming conventions, making sure that everything in the model has a consistent name and is consistent from model to model. So we have very prescriptive names about how we name everything, and you can see that list of things and how specific we will get regarding how we name different aspects of the model. And then we get into our content library, which for us has been something that we've spent a significant amount of time on developing, and it's very specific to the needs of an owner. So our content library typically isn't going to work great for, say, an AEC firm who wants to actually build a building, but we've had to think through what our content library how it should function and how it should act, and what we should include in it from an owner's perspective. So thinking about naming convention again, we have a lot of families who want to make sure it's easy to find them. We use mesh format to kind of organize the top level of our content library. But we had to ask a lot of questions about, what are we going to model? It goes back to the whole initial list of what's in an owner's model. And what level of detail are we going to be modeling? Are we going to put in families that are buildable, that are very specific? They are the exact material. They are the exact brand of toilet. Or are we going to focus on being more representational? And we really focused on being more representational. Keep in mind, again, we're talking about supporting the planning side, but even if we're supporting the operational side, the data doesn't have to necessarily live inside the Revit model. If we have got a toilet and we have a CMMS out there that we can link to, you have a way to add additional data that maybe isn't necessarily directly in the model. But this is a decision we came to, focusing on representational. It is, we want to know there's casework here. We want to know its dimensions. We want to know there's sinks here. We want to know approximately what they look like. We want to know there's a chair there. It's this approximate type of chair. But beyond that, we want to be careful about not adding too much additional information, partly because it just takes too long to collect and then too long to model. And it makes your models a lot heavier. And we did not want to be in a situation where people wanting to use our models had to have a particularly large computer. And except with the exception of some of our extremely large buildings on campus, pretty much any regular computer is going to be able to open up our models. We also focused on our families being parametric, so we don't want to have 10 different types of tables that are all just different sizes. We want to be able to stretch and resize things as needed. And so currently, we have around 800 families in our library. And we try to be very careful about not letting this grow too much. It's going to as we hit different types of buildings, but we try to be very careful about keeping this reasonable. So our families are lightweight. They also look really good two-dimensionally in general. We understand that a lot of our users are still going to be looking at models, looking at our data in the two-dimensional format. And so we've really focused on ensuring that all of our families make sense two-dimensionally. For example, say a bunk bed, which we have in our residence halls. How do you know it's a bunk bed if you're looking at it two-dimensionally? We actually have A2 that's on top of the bunk bed to let you know that, hey, there are two beds here. So it's little things like that to make sure that our users, who still, in a lot of cases, are using a 2D representation of our space, understand what we're looking at. So that's our content library. Now I want to get into our processes, and really, which is what the bulk of the effort that we've had at kind of developing this solution for ourselves. And for us, we're using students. While this process can work for anybody, part of the reason why we've gone to the level of detail we have had in our developed in our process is because we're using students that change every year, and we start with training for them. We have a week of training for them. We assume they don't know Revit at all, and we train them on our process and in Revit the first week, and then we have some additional training over the next 4 to 6 weeks as they hit different milestones in their project. But the first step is gathering, and they're going to gather any record documentation we have about the building, and they're going to go out and do a field verification of the building. Then they're going to get into the modeling process itself, which is obviously the most lengthy part of the process. And then they're going to go into a check process. Now, again, we're using students, and we want to ensure that the quality of every single model is as high as it can be and is as consistent as it can be. And so we have a number of ways for the students, in our case, to audit their own work, and then we turn it over to our BIM coordinator, who then audits their work and does some additional auditing, and then they iteratively work through their model until the BIM coordinator is happy with the quality, and then we consider that model done, and it gets published out to everywhere it needs to be placed. So digging this a little bit further, I mentioned that we do have a very detailed process because of our students, because we have high turnover, and so we've been able to develop a process that's relatively standardized and really has tried to handle for every situation we've come across. And because we've been doing this for almost 9 years now, we've really been able to refine this process to make it as efficient as possible, but as also as error proof as possible. And of course, you're going to have mistakes every once in a while in somebody building a building, but try to make sure that the process handles for everything that we've seen over the last 9 years, and ensuring that the end result is as efficient as we can get it. It starts with setup, and what do you do when you first set up your model? How do you, just real practical stuff about making sure you arrange your field verification and set up folders with the right files. And it moves in then to our field verification process. Now, for us, there's a lot of our students have never done any kind of field verification outside of maybe a very minor project they might have done in class. And so we want to let them know, hey, this is what you do freely for field verification. This is the kinds of information you want to collect. This is the kinds of things you want to take with you when you head out to the building. We want to ensure at Ohio State that our buildings are within 2% of actual measurements, and so they need to do some initial measuring off of the AutoCADs. So we have existing AutoCADs for these buildings, and are they accurate? Do we need to dive in a little deeper on this building and take some more measurements? So we want to see if we're going to be within the 2% deviation. What are you going to do during your building walkthrough? We've been moving to 360 cameras for all of our walkthroughs now, which has been a game changer for us. Been much more efficient and gets us a lot more data. But we have best practices for using a 360 photo or camera too. And how do you make sure you know where you took that picture, and what kind of measurements do you need to take, and what kind of other data do you need to make sure you're getting while you're in the field to make sure they don't miss anything. We don't want them having to go back out again if they don't have to, because we just waste more time doing that. And then what are you going to do when you get back? What is the process for ensuring that you've collected everything and you put it in a place that you can find it later? And then naturally you get into the modeling. And so what is the process for getting the file initially set up? You open that Revit file for the first time, and we got to start setting things up. We got to set our levels up, and we've got to link in our existing AutoCADs. And how do you do that? What's the process for that? What's important to note about our process here is that we do assume that people know Revit. It's not going to teach them the ins and outs of how to do every part of Revit, but it is going to be pretty prescriptive on how to do a lot of the individual pieces and walk through screenshots to ensure the students haven't forgotten since our training how to do a particular thing. And they're going to set up column grids, usually the first thing they do, and then work on exterior walls. And then they're going to get into GIS. And I take just a quick pause here to talk about survey points and project base points. And if I'm sure there's a number of people that are listening to this that have dealt with survey points and project base points, and we've found it very challenging to make this work correctly in our environment. And we've spent quite a bit of time trying to get this perfect, and spent a lot of time internally and a lot of time with our consultants to get it right. And there's some real big reasons why this matters. First of all, we want to be able to link Revit files together. If we have adjacent buildings, or we want to combine several buildings into one model for whatever purposes we might have, viewing it, rendering it, looking at floor plans that are adjacent to one another, And if you don't get this right, that can be a little bit more challenging. We want to work correctly in BIM 360. We want to work correctly in Navisworks. And if you don't set this up quite right, it might work in one but not the other. And we want to be able to push these GIS points out to our GIS, which we use Esri GIS at Ohio State, without having to re-enter any information when we get there. And so where does that go correctly? And so we've got a very detailed process of exactly how the GIS coordinates are included to ensure that they work in all environments and everything matches up correctly once it leaves the Revit world. Then we move on to building your walls, building your doors, building your floors, doing the different parts of modeling the building, and then getting into your stairs, your casework, your plumbing fixtures, things that are not quite as architecturally significant in the sense that they're going to change square footages or anything, and getting into your model in place for things that we may have not thought of or we're not going to create a family for, and then into your additional components, your ceilings, those types of things. But another aspect that's really important to us as an owner is the rooms. Making sure that we've set up all the rooms correctly, that we've got the room numbers set correctly, that we've developed. We use a space ID at Ohio State, and making sure that has been entered correctly. We also talk about how to develop gross area plans, because that's obviously as an owner critical to us too in the way that we do our reporting, and exactly how do you build that gross area plan, and how do you report on it. Once we have the model complete, then we're going to start setting up our views. We have all sorts of default views that we want to use. We have templates that we've built around that to ensure that we have consistency in the way that it looks. And then from that, obviously, we're going to build some sheets that we have a tool that helps us quickly and rapidly build those sheets from our views. So once we've gotten to that point, they've completed the process of modeling. Now it's time to ensure that they did it right. And so they have a process of going through a self-audit, checking some things that we know that is commonly occur. And then they're going to move to use a tool called Syllabary, which is an IFC-based tool. It's not inside of Revit. This allows us to check a lot of geometry issues and some other data-related issues. And they'll continue to use Syllabary until they get a clean report on that. And then they're going to move into using Revit Model Checker, which is a free tool that Autodesk has developed. And this allows us to check a number of things that Syllabary can't check. Nice thing is it's also internal to the software, so you're not having to go between two pieces of software to try to resolve something. You can usually, from the report, go right to the particular item at hand and correct it. And it's easy to find those things there. But once the student has done Syllabary, has done their self-audit, has done the Revit Model Checker, then they're going to pass it off to the BIM coordinator, and she's going to run Syllabary Model Checker again, make sure that she's comfortable with the results, and she's going to do her own audit, which really focuses on the things that cannot be checked in Syllabary or Revit Model Checker. And so she has a process for that too, standardized document that ensures that she doesn't miss anything as she goes through things. She's going to document things up, she's going to pass it back to the student. And they're going to iteratively go through this process until she's comfortable with the quality of the model. So that's building a model. That's our process for building and checking a model. We have a number of other processes that we've actually included because these are things that happen all the time, and we want to ensure that they are done, again, consistently into a standardized way. We have how do you link an adjacent building? So when two buildings touch, what's the right way to do that so that it's consistent across every single building? How do you combine multiple buildings if you want to look at a bunch of buildings? In this case, this is actually 6 or 7 buildings that are actually combined. They're separate buildings combined in one view here. And this happens obviously frequently too. You want to look at a certain portion of your campus or a certain collection of buildings. What do they look like? What's the proper process for that? What's going to make sure that this is consistently done? And we have a number of these throughout our university that we've set up. We also ask the students to do some renderings. We want to ensure that we have some nice eye candy to show off to leadership and others to show what we've been doing. And we have some standards and some processes. So this is how you do an interior rendering. Here's how you do an exterior rendering. A lot of information in here about the best way to do it, and then also how to use Autodesk's cloud rendering services too. One of the big things that we have to do on a regular basis, especially now that we have a project delivery standard that requires Revit deliverables, is we have to bring models in from from the outside that obviously were not built to our internal standard. Now, we do in our standard have a couple of things we want them to do when they're building the model to make it a little easier for us to bring into our environment, but we're not going to be too prescriptive about that. And so we have a process we've developed to help bring these models in, to clean them up, and then at the end, have them look and feel consistent with our internal models, except for the fact that they're going to have a lot more data in them than our existing models do, our CAD to BIMs. And so we actually use BIM Explorer quite a bit for this process. It's one of the tools we found that really helps us clean up our models quickly. We also have a tool, which I'll show you in a moment, that helps us clean up all the views. On the left, you can see a traditional project browser that has all different views from a project, and we only want the stuff on the right, so we want a lot less stuff. So we want to be able to clean up all that. Going back to that, and to some extent, the BIM to BIM is part science, part art. Every model that comes in is a little different, but our process, after doing a number of models, probably over 20, 25, 30 models now that we've cleaned up and brought into our environment, tries to handle for the majority of the items that we come across in our environment. Now, we don't actually let students do BIM to BIM processes. It's a little too tricky for most students to do because there's always some judgment calls you have to make. But we developed a process that helps us really get through it and make sure that at the end we have something that's consistent with our internal models, so that we're working with the same environment. And lastly, we have some additional resources. We have all of our naming conventions, which I mentioned earlier, in one place. And we've also developed those model development levels. Mentioned the owner model, that's what this base model is. We have a different one for residence hall, like I mentioned. We have different ones for parking garage. We actually have another one for athletics that we haven't documented here yet. We also have another level, which is called the additional data model for some certain models around campus. We spent a little extra time and gone to a second level of detail. And actually, models that come from BIM to BIM, this is the level of detail that we maintain. So we'll say that we have enough staff to maintain this level of detail going forward. So that's base model plus the additional data model. So that's our process. And I said that's 9 years of development, refining it, developing that content library. You can imagine with 800 pieces of content in that library, and the easiest family might take you an hour to develop from scratch. Even if you're downloading it offline and trying to find it somewhere and cleaning it up, you're talking about a minimum of an hour. Some of those, like maybe very specific doors, might take up to a week. So there's a lot of hours that we've really put into developing that content library. But one of the things that we developed over the years is some customized add-ins that really sped up a number of our processes and also made some of them a little bit less error prone. So I'm going to walk through a couple of these. First, we number all of our cubes, but we want the cube numbers to be associated with the room number. And so we have something called a subspace tool that helps us load that up really quickly in the model without having to hand type it. And similarly with our Space ID tool, it'll actually concatenate the building number, the floor designator, and the room number and put it into a Space ID. And this is what drives all of our systems at Ohio State. Everything uses that Space ID tool as the unique identifier. One of the other items that takes us, whenever we make a change, we have to export new DWGs. We need to save the existing RVT. We need to push out PDFs, DWGs, or DWFs, and the IFCs. So you have all these files that need to be exported every time that we make a change. And so you build a little tool to make it really easier for us to do this, and also specify which view we want to be used. A view template, I should say, is used when we push out that particular file type. And this saves us quite a bit of time and just simplifies things for us. Make sure we don't miss anything. From the BIM to BIM side, I showed that we want to clean up all those views and sheets, and so we have a tool that helps us very quickly clean up the views and sheets and determine which ones really need to be saved and which ones can we actually easily get rid of. We also want to get rid of any lines or fill patterns in those models, and this very rapidly does that for us too without us having to find them individually. And for the benefit of both the CAD to BIM and the BIM to BIM process, we have a sheet creator tool which allows us to build one sheet and then use that one sheet to then build all the rest of the sheets. And this just speed, again, it speeds the process up and reduces some of those repeatable errors that occur when you're doing something over and over again. Lastly, the one tool that probably has saved us the most is our file upgrader tool. As you know, you have to upgrade Revit models every single year if you want to use the new version of the software. And we have around over 400 total models in our environment, if you include discipline models. And to be honest, this process of upgrading every year at this point would have actually shut down our project, and we were because we simply couldn't manage it from year to year. Right now, if we were to have somebody manually update our models, it would take us at least a month, maybe closer to 2 months of actual man time to actually complete. There's a lot of intricacies as to why that is. You can't just use the Autodesk's batch uploader. It doesn't actually work correctly in our environment, especially the way that we have our model set up. And so we've been able to develop this tool that backs up a copy of the model, copies a copy of the model to our public directory after it's upgraded the models. And that upgrade process checks for corrupted models so it doesn't blow up when it hits those, and ensures that any warnings or errors are actually suppressed so we can get through as many of these models as possible. And with the most recent iteration of the model, we completed the entire upgrade in 2 days, overnight, unattended. So we really had no more than about an hour's worth of time. And this tool alone for us has saved us tens of thousands of dollars in labor costs. It's been a game changer for us. We just simply couldn't continue the project if we didn't have something like this. And from the last piece on a process perspective, I'm just going to talk very briefly about this piece. But we've got these great Revit models, and we have a very robust Esri-based GIS environment, and we want to be able to rapidly go from those Revit models into our 2D and 3D Revit environment. And so we've developed a number of methods to ensure that we can do this. Now, 3D we're still working on. We have a process for getting there, but we don't have a good way of visualizing the entire campus in 3D quite yet. Technology is not quite there, not at the level of the detail of our Revit models. But we've developed processes using something called Safe Software FME. If you're not familiar with it, it's not important. It's just that we have a method of exporting an RVZ model from the Revit, and to be able to use that model to get us to a 3D and a 2D view, file type that can be used within GIS. And this has been helpful to us to continue to expand the use of our GIS and have things like floor plans and, in very limited sense, 3D views of our campus buildings in GIS. A tool that we're actually in the middle of implementing right now, we're actually loading it up with data, is imagine it's Clarity. For us at Ohio State, where we look more like several different companies collaborate together. We have all separate IT organizations. Our IT organizations don't talk to each other very well. And we're having more and more customers use Revit in their internal workflows. So we have lots of furniture models out there that are linking back into our architecture model. We have one department that's been building a lot of MEP models using laser scanning and their own students. We have another that's using Revit to manage a lot of their equipment. And we need to have a better way of managing those linked-in models instead of just passing models around using something like Box. And so Clarity combined with Revit Server is going to allow us to enhance the way we share models, so we're all working off the most current version of the models at any time. The other thing it's going to allow us to do is some data extraction. We get asked questions like, how many toilets do you have on main campus? So tell me of these 400 or 500 buildings, how many toilets you have, or how many exterior doors, because we want to put a no smoking sticker on all the exterior doors. Well, that data exists in our Revit models. We just don't have a good way of getting at it for that number of buildings. We have to open up each one individually. And already we're able to see how we can extract data easily from Clarity once all the models are actually in the system, and be able to get the kind of reporting out that we really want to be able to do. There's a number of things that we want to be able to automate further. Some of the things I already mentioned, those plugins, are going to be able to be automated in Clarity, plus a lot of other stuff we don't do today, like making sure we're checking the health of our models on a regular basis without having to personally open them. And so there's a lot to learn about Clarity from our perspective. We're just getting into it, and I think there's going to be a lot of hope for some automation that's going to reduce our time that we're spending on doing really basic tasks, and then doing things that we actually don't do today because we simply don't have time at all. And then lastly, using Clarity as a way to have a 3D web viewer of our models, and then looking at how we might be able to connect different types of systems into those models, so we have a way of accessing all sorts of interesting facilities data in field through a web browser. And so we have a lot of work ahead of us to get Clarity fully in our environment, but we have it has a lot of promise for us to really change the way that we do things. So I want to wrap up by just sharing with you some of the lessons learned that we've learned over the last 9 years of doing this process, 8-9 years. And these lessons are really from the perspective of a single owner with lots of buildings, and we're going to manage those buildings for a long time. And I want to make this clear is that if you compare it, say, to if you're in an AEC firm, where you're going to be working with that model for maybe a couple of years if it's a really big building, but after that, you're going to set that model on a shelf, and you don't really need to work with it anymore. And so we've really had to think about, from our perspective, that until Revit goes away, we're going to be managing these buildings in Revit. And so we're probably looking at a couple of decades minimum of keeping these models going in our environment. So the first thing is this idea of proper planning and focus. Again, going back to those three questions and what I started off with, what do we need to model? What's really actually important for planning and operations? And what can be reasonably maintained? It's great to collect the data, but if you can't maintain it, no one's going to trust it after a couple of years. And really asking that question, what does have the best ROI for the organization? What data that I'm adding to these models is going to have the best ROI? And I don't think that this process needs to take 3 years. I think you need to take 6 months or get focused on it, ask the questions, and then move forward. You're not going to get it perfect. There's no doubt about that. We definitely made some mistakes early on, but we've learned from them. But doing your best effort to find out what your customers want and what your organization needs to get the best ROI for what you're going to build. Effective training is critical. Like I mentioned, we use students. Maybe in your environment you won't use students, but having really well documented processes and training those temporary workers if you're using that. But more than that, if you're going to use Revit, if you're going to build these models, you've got to bring all your users up to speed. And we conduct several trainings throughout the year that we bring in a trainer from Imaginet and actually do several one-day trainings where just here's Revit, here's how you get it around in a model, here's how you get a schedule, and then a couple 2-day trainings. And here's if you want to start doing some furniture layouts or some minor renovations in Revit and you want to do some renderings of that, how do you do that? Making sure that if we're going to spend the time to build these models, we want to make sure our organization can access and use all this great information that we've been developing. Continual improvement, but to a point. For us, we adjusted our processes, our templates, and a lot when we worked with the Med Center buildings. And when we came to start the rest of the campus, we realized that we wanted to make some adjustments to the way that we did things. That included adding in Syllabary and adding in some of the plugins that I showed you. And it meant that we had to go back and update all those models so that they matched all the models going forward. So we're not going to keep making massive changes to the way that we do things at this point, simply because we can't go back and adjust 300, 400 models. But we made a lot of adjustments over the last 8 years to really refine the process. And that goes to the families also, making sure that they work best. And oftentimes we'll go back and say, why do we have this family? And maybe it's best to combine this with something else. So just continuing to look at how we do things and making the appropriate changes. Connected to that is the standardization. When you get to this level of having this many models, if it's not standardized, it falls apart really quickly. It's very hard to manage. And so the standardized process, the standardized templates, standardized families, all these naming conventions, and our BIM project delivery standard standardizes certain other things as in our models that get turned over to us at the end of projects. So that's another method of standardization we've used. But that standardization leads to the ability to automate. Our model checking software doesn't work as well if it's not standardized. Our failing management software doesn't work as well. Our plugins depend on a lot of the standardization that I've mentioned because they just simply don't work. But because we've been able to standardize, we've also been able to have these great plugins that really speed up the process for us and make this whole environment that we're trying to build a little more reasonable for us. And lastly is this idea of partnering and collaborating. From day one, we've had some excellent consultants that have worked with us over the long term. The reality is we don't have the knowledge internally, and we didn't at first, to be able to do any of this. And so we've really depended on some very smart people outside of our organization to help us understand what is BIM, what is Revit, how do we build this stuff, what is the right way to do things, help us build a process. We are now very good at this stuff internally. We rarely have to ask, say, for instance, our consultants Revit questions. Like we did the first couple of years where we were basically having them on speed dial. But we still every once in a while have to reach out and say, hey, we're having a struggle here. So we need that external partner to really work with us. But also internally, it's important to get all of your internal stakeholders on board, or as much as you can, understanding what they need, what they want, and how they're going to be using the system. And not just simply going off into our our fabric-covered cubes and hanging out there and coming up with an idea, but understanding what our customers need internally at the university and delivering something to them that is going to be the most useful to them. And so with that, I'm going to turn it back over and open it up for questions.
Wonderful. One moment while I end today's recording.